Hello, pre-algebra students, and welcome to Chapter 9.2, Simplifying Square Roots. Yesterday, you learned how to find square roots. Today, you're going to simplify radical expressions. Let's get started. Take a look at these two expressions, and let's compare the following pair of products. First, we have the square root of 4 times the square root of 16 equaling 2 times 4, which equals 8. Now look at the next line here. Here we have the square root of 4 times 16, which equals the square root of 64, because 4 times 16 is 64. The square root of 64 is 8. What does this suggest to you? This example illustrates the product property of square roots. The product property of square roots tells us that the square root of a times b is equal to the square root of a times the square root of b. This works as long as both a and b are greater than or equal to 0. Let me show you a number example on the next slide. If we're to take the square root of 9 times 7, that would be equal to the square root of 9 times the square root of 7. 9 is a perfect square, or 3, but we leave the 7 under the radical because it's not a perfect square. So your answer to that problem would be 3 times the square root of 7, and it would be written like this. We can use this property, the product property of square roots, to simplify radical expressions. A radical expression is in simplest form when it follows two rules. The first is that no factor of the expression under the radical sign has any perfect square other than 1. So if there's a 4 or a 9 or a 16 or any other perfect square under the radical sign, it is not in simplest form. The second rule is that there are no fractions under the radical sign, and there's no radical sign in the denominator of any of the fractions in the expression. So, in this book, all of the variables that we're going to be working with in radical expressions are going to be non-negative numbers. We'll throw negative numbers at you in the future. All right, let's try simplifying a radical expression. Our first step in simplifying a radical expression is to factor the number under the radical. We're looking for the greatest perfect square factor. You may use whichever technique you prefer for finding the factors of 180. The greatest prime factor, however, is 36. 36 times 5 equals 180. So we factored here using the greatest perfect square factor. Now we're going to use the product property of square roots, which just means we're going to split these apart. Square root of 36 times the square root of 5. Now we're going to simplify. The square root of 36 is 6. We leave 5 under that radical sign because it's not a perfect square. We can take out the dot here, leaving our final answer is 6 times the square root of 5. So this is our simplified expression of 180. The square root of 180 right here as 6 times the square root of 5. Now let's try simplifying a variable expression. First, we're going to factor using the greatest perfect square factor once again. This will be a little bit simpler with 24 as our number instead of 180. So the factors of 24s squared would be 4, that's our greatest prime factor, times 6 times s squared. All right, so now we're going to use that product property to break this expression up. Square root of 4 times the square root of 6 times the square root of s squared. Well, the square root of 4 is 2. The square root of 6 is not a perfect square, so we're going to leave that radical sign there. And then the square root of s squared is simply s. So our final answer will be, we're going to rearrange a little bit here, 2s times the square root of 6. Now that we've examined products, let's take a look at quotients. Notice in our first example here that we have the square root of 100 divided by 4. That is equal to the square root of 25 because 100 divided by 4 is 25. And the square root of 25 equals 5. Now look at the next equation. We have the square root of 100 divided by the square root of 4. Well, the square root of 100 equals 10, and the square root of 4 equals 2, giving us the fraction 10 over 2. That is also equal to 5. What does that maybe tell you about dividing square roots? Much like the product property, the quotient property of square roots is going to help us simplify radical expressions. Here's how it works. The quotient property tells us that the square root of a divided by b will be equal to the square root of a divided by the square root of b, as long as a and b are both greater than or equal to, you got it, 0. Showing you that with numbers, if we're going to find the square root of 11 divided by 4, that would be equal to the square root of 11 divided by the square root of 4. The square root of 11 simply stays square root of 11 because 11 is not a perfect square. However, 4 is a perfect square, leaving us with 2. Let's try using this property to simplify a radical expression. Okay, let's give this a try. This question is asking us to find the square root of 13 divided by 36. We begin by simply rewriting or splitting apart this expression using the quotient property of square roots. So I've rewritten this as the square root of 13 divided by the square root of 36. 13 is not a perfect square, so we keep it under the radical. 36 can be reduced to 6 when we find its square root. So our final answer is the square root of 13 over 6. See, that wasn't too bad. All right, give this a try on your own. For these 4 problems, you're going to simplify the radical expression. For problem number 1 and 2, use the product property of square roots to find the simplified version. For 3 and 4, use the quotient property of square roots. Press pause while you work. There is one more idea to learn about after you finish these checkpoint problems. Now that we've learned to simplify radical expressions, let's use one in a real-world problem. So let's say we're investigating a car accident. So after a car accident, a police officer will measure the length, L, of a car's skid marks. L is in feet, by the way. The expression, the square root of 27L, gives the car's speed in miles per hour when the brakes were applied. So first thing we're going to do is we're going to write the expression in simplest form. So if our expression is the square root of 27L, we're going to solve that by first factoring. The greatest perfect square factor of 27 would be 9. That would be 9 times 3 times L. Oops, that wasn't quite big enough, was it? Now we'll break this apart using the product property. So this will become the square root of 9 times the square root of 3 times the square root of L. So this will become 3 times the square root, we can mash these back together, of 3L. Okay, so our simplified version is 3 times the square root of 3L. You'd write it like this. In the next part of the question, let's say that the skid marks are 125 feet long. So that's our value of L. So let's substitute L into our equation. 3 times the square root of 3 times 125. Once again, we're going to multiply. So 3 times 125, which is going to be 375. Let's use our calculator to approximate the square root of 375. And let's take that times 3. And that's going to give us an answer of, well, let me fix that, of approximately 58 miles per hour. So the police can estimate that the car was going approximately 58 miles per hour at the time the brakes were applied. Now, depending on what the speed limit is in that area, that's either good or bad news for the driver. All right, that takes care of chapter 9.2. I'll see you tomorrow to do some practice on simplifying square roots. Have a great day.